Hey everybody, welcome to the Daily Space Weather. We're looking at a large coronal hole associated with the South Solar Polar region. We've got geomagnetic storm conditions already arrived, and a G2 class geomagnetic storm moderate in the forecast. I'm your host Dan, aka smAsho, and welcome to the Daily Space Weather. This is the southern hemisphere of the closest star in 193 angstroms. We've got a whole bunch of great views for you today. Check it out. Here's a colorized magnetogram. We've got one major sunspot here, sunspot 2816, which is the one below my pointer. These two groups out here, sunspot 2814 and 2815, have degraded since yesterday. Here's another full disk view. This is 171 angstroms. We've got some more views here from the beginning of the video. We'll add some at the end as well. Here's 304 angstroms. There is some likelihood of coronal mass ejections happening sort of in the Earth-facing vicinity. And likelihood of solar flares has gone up as well. This sunspot down here, 2816, is indeed a beta-class sunspot, which is more likely to produce solar flares as well. Here's a close-up of it in 131 angstroms. One of the many ionized ultraviolet light emission spectral states of ionized iron. And here's my personal favorite, wavelength 171 angstroms. Continuing on, here's a diagram of the solar system. There's where things will be in a week on April 24th. Here's a star chart. If you're up before dawn and you have a clear sky and a view of the ecliptic, you may have the ability to see Jupiter and Saturn rising before the sun. There are them, the two largest planets in the solar system on the ecliptic. And let's get back to solar data. The radial flux, which is the output of the upper chromosphere and the lower corona, now at 77. Here's the one-year chart of that. The black line up top is the radial flux. The red line below it is the sunspot number. And here's a space weather enthusiast dashboard. They're actually forecasting, NOAA is forecasting a G2 geomagnetic storm. So we're already in G1 magnetic storm conditions at a KP of 5. And let's talk about our patrons. Thanks, patrons, the true source of funding for these videos. Please consider becoming a patron if you like the content and you'd like to see it to continue to exist. Consider becoming a patron at patreon.com/smAsho. You'll get all kinds of early alerts and other perks that nobody else in the world gets. Let's check earthquakes over the past 24. And while we don't see any major quakes, we did see some deep ones, such as this 4.5 at the Philippines. This 5.4 at Fiji, that one over 570 kilometers of depth. There was a 5.0 near the Kermadec Trench there, north-northeast of New Zealand, as well as a 5.4 at Indonesia and another 5.2 at the Kermadec Islands. Also, Banda Aceh saw a deep quake at a 5.0 magnitude. Mariana Islands saw a 5.3 magnitude quake. Chile saw a 4.9. And let's talk volcanoes. Soufriere volcano has changed the aerial view of the island. So here's the island of St. Vincent, and here's La Soufriere volcano up here up top. This is a false color image by a NASA satellite, and there's what it looked like after the volcanic eruption. You can see the northern part of the island having turned gray there with volcanic ashfall. Article here on SciTech Daily once again. It's our channel's favorite publication, I think. Before and after imagery of La Soufriere, the stratospheric scale injecting volcano on the island of St. Vincent. Let's see what else has been erupting. Abiko is on the list, flight level 090. It's a 9,000-foot ash plume. Sakurajima 6,000-foot ash plume. Sinabung, 13,000-foot ash plume at Indonesia. Luatolo, now on the list, exploding. Flight level 070, it's a 7,000-foot ash plume. Samisopochnoi in the Aleutian Islands continues to explode, produces a 10,000-foot plume of volcanic ash. Fuego in Guatemala, 15,000-foot plume as it explodes. Sangay exploding, 20,000-foot ash plume in Ecuador, as well as Revenador in that same nation exploding as well, 14,000-foot ash plume, 25,000-foot ash plume at the Peruvian Sabancaya. And Soufriere currently producing a 15,000-foot plume of ash. Which brings me to our public service message. Please do not pole vault the caldera. Here at youtube.com/smashomash or perhaps bitchute.com/smashomash or wherever you're watching the content, we prefer that our viewers do not pole vault the caldera. We need the views and the comments and you to share the content on your social media. This public service message brought to you at great personal risk and expense from smashomash.com. No major solar flares over the past 3 days, although we did see a mid-level B-class flare here. That one had a peak flux moment of about 10 after 6 p.m. Universal Time. It's a 3-day chart of the GOES X-ray flux. No major spikes in the proton flux. No coronal mass ejections have struck recently. No surprises there. Here are the continued sawtooth, spiky-looking patterns on the GOES magnetometer, a typical thing we see when coronal hole wind streams arrive. As forecasted, it's 3 days of GOES magnetometer. And let's take a look at the ecliptic plane, the top view. And this is part of the National Sunspot Observatory, by the way. If you're wondering where the data comes from, it comes from 51 ground-based magnetometers. 51. As well as magnetometers on stereo A and stereo B. Anyway, you can see the Earth is solidly in a South Pole current sheet, shown here in red. Here's the line of sight plot of the same the same data, essentially. And that blue line shows you the extent to which one of the polar fields contributes to the BT, the total field measured from the sun, which is essentially a product of these two fields, the south and north solar polar fields. When you see the blue line north of the solar equator like that, that means that the South Pole is in charge, and vice versa when the North Pole is in charge. And here's a line of sight coronal hole plot, and we are seeing some progression here of the solar cycle. This large coronal hole system associated with the South Pole, not quite reaching up to the equator. Expect to see increased activity coming soon in the northern solar hemisphere as well. Currently, most of the activity, including the sunspots, are in the south. And here is an up-to-date set of imagery on that. So you can see 2816, significant sunspot group there. And we do see some filaments here, and some of them are not showing up. Some of them are someplace around this area as well. And again, there is some likelihood of an Earth vicinity coronal mass ejection. We'll keep you posted on that. So here you can see the KP index has been at 5 over the past 9 hours, having briefly reached back down into geomagnetic unrest and then back into G1 geomagnetic storm. We are expecting this, according to NOAA, to get up here to a KP of 6. So a moderate geomagnetic storm is forecasted. Our patrons would already know it. And next we'll take a look at the real-time solar wind. So we saw quite a high-speed coronal hole wind stream here. Current conditions have come off their highs. Current conditions are 561 kilometers per second and a 13.82 protons per cubic centimeter for the density. We did briefly see it get above 600 kilometers per second here, and we can expect to see this persist for the majority of the day here at these high speeds. Don't be surprised to see an additional density spike here also. I think there might be a second pulse coming. But in any case, that's the current data. Next, we'll look at the Geospace magnetosphere movies. Here's 4 hours of data. We're going to show you velocity, pressure, and density. The first one is velocity. It's 4 hours of data. A great opportunity for me to shut up for a minute and let it play. A bit of turbulence there in terms of velocity. And those high velocity zones behind the Earth are Earth's plasma being reintegrated into the solar wind. Here's the density. Keep in mind this shows high density in dark blue and low density in white. And that's in protons per cubic centimeter. Last but not least, magnetohydrodynamic pressure, measured in nanopascals. So quite a homogeneously high pressure environment around the Earth right now, save for the plasmasphere, which is this little more neutral area right here. And we'll also show you ground magnetic perturbations. Here are Geospace Delta B at the poles, changes in Earth's B field, also measured in nanotesla. You can see the similarity between the shapes of the two poles. And leave us a comment if you think that the South Pole is splitting in two also. There is less ability for independent people to track that, as there is pretty much nobody hanging around the South Pole, except in very, very limited quantities. It's, shall we say, an inhospitable place. But anyway, there's 4 hours of data. And we actually see the magnetic perturbations calming down here toward the last portion of that 4 hours. Here's a different view. Let me rock this back here. Here's a different view. The flattened view of Earth from the equatorial plane. And we'll show you the Aurora forecast here as well. Let me bring that back to where it was. I'm just gonna actually ride this through here. Anyway, that's 4 hours of data. Geospace Delta B, folks. Next, the Aurora forecast. And not expecting to see any auroras in Tasmania. Quite a bit over Greenland and Iceland and Norway, Sweden, and Finland, as well as a large portion of Canada. A little bit of likelihood in places like North Dakota and Minnesota and Montana as well showing up there. Next, I would invite all of our viewers to check out our own website, smAsho.com. You can find our social media links and other links to our merch shops there. If you want to support the channel that way through some merch, feel free. We greatly appreciate your support. Also, on our forum, if you'd like to win a free month for May on Patreon, all you got to do is enter our slam poetry contest. Perhaps you'll win. We've got one entry so far, which means that entrant is guaranteed to win unless somebody else decides to enter the contest. The slam poetry contest is pinned on all of our topics, by the way. It's a globally pinned sticky note. So again, check out the forum, smashomash.com/forum. Also follow us on Twitch, twitch.tv/smashomash. Thanks to our YouTube subscribers. Keep in mind, if you're viewing the video anyplace else, the majority of our content is on YouTube, youtube.com/smashomash/playlists. Check those out if you haven't. We put out a lot of stuff besides space weather stuff. And we've also got exclusive content on BitChute. Let's do a cosmology segment real quick. We're going to generate a random number. Today's is 978, which coincides with some object at the Neil Gorell Swift Bat X-ray Observatory. By the way, BAT stands for Burst Alert Telescope. And 978 is 0ES2132 plus 50.9, which is a catastrophic variable / Dairy Queen Herculean. I don't know what DQ her means, but it's some kind of a catastrophic variable star. So it's not all that variable in X-ray, as you can see from the historic chart going back 16 years here. We actually did see some powerful transient bursts from it, causing the scale to expand. That's the 30-day chart. And let's take a look at this on Aladdin Light. You can link to it right from the Neil Gorell Swift-Bat X-ray Observatory through SIMBAD. And we'll take a look at this catastrophic variable in a couple wavelengths if possible. So here it is on the 2-mass. How about pan-stars? There it is in optical light, pan-stars, one of the higher resolution telescopes that you'll find. And let's see if it shows up on the Chandra. Here it is on the XMM Newton, the multi-mirror project. And we'll close it out there. That's today's random object. 0ES2132 plus 50.9, the catastrophic variable / DQ her. Which, that just escapes me what that is. Let's talk about the heliosphere. This is an artist's rendition of the heliosphere. So the space outside of the sun's magnetic shell environment is very different from the space inside of it. And somebody's taking a look at that. Now, we don't really know how the heliosphere is shaped. This is just an artist's rendition, obviously, since we can't view it from this perspective. And you can find an article here on phys.org entitled NASA Rocket to Survey the Solar System's Windshield. So this is the SHIELDS project, and it is a sounding rocket that will take fleeting moments to fly up above the Earth's atmosphere sufficiently to see, I believe it's using radiometry, but the emission line dynamics spectrometer. So, and we're going to show you a little bit more information about this momentarily. I'll just let the article scroll here. We know very little about the local environment, but we do have some interesting information to share. Quote, "There's a lot of uncertainty about the fine structure of the interstellar medium. Our maps are kind of crude," Harris said. "We know the general outlines of these clouds, like the local environment, the local bubble, the local chimney, etc., whatever you want to call it. We don't really know what the other cloud is like. We don't know what happens when you cross a boundary into that cloud. There's a lot of interest in understanding what we're likely to experience as our solar system makes that transition." I would tend to agree. And I would tend to direct our viewers to Plasmascape. So if you head to plasmascape.com, you'll find the link to this. If you click on number 5 and you click the A tab, it'll bring out these tabs. And the point is that this hourglass-shaped structure right here, this is what we call the local chimney. This is the interstellar space through which the sun is currently moving. This tab here is the solar apex, because with relation to other objects in this interstellar chimney, which are all moving the same direction, which we'll get to in a moment, the sun is actually moving toward this side. And this right here, the solar apex, that is a reference to the sun's motion within the interstellar chimney. The entire chimney itself is actually moving in this direction toward Deneb. So I may not have that exactly lined up, but Deneb is on the galactic plane someplace out there to the left of the galaxy. And if you zoom into different levels, you'll get different zooms here. So 4 is a little closer. 3 is going to show you a bubble-like heliosphere. There's that bubble-like heliosphere. And keep in mind that this is not likely the shape of the heliosphere. It's just to give you the ability to three-dimensionally visualize. Number 2 zooms you in farther, and number 1 will zoom you all the way into the inner planets. So if you move this map around, you want to see the direction that the sun's moving with relation to other objects. If you look at Deneb, you can orient this toward Deneb. And if you follow the galactic plane, you'll find Deneb. Something which I'm currently having trouble doing. I apologize. Just give me a minute here. I will get this to rotate. And we apologize if we're making our viewers dizzy. All right, so there's Cygnus, and there's Deneb. So that's the direction that the local chimney is moving, folks. It's moving in this direction toward Deneb. And the sun is moving off to your right there with respect to objects within the local chimney toward that tab that says solar apex. Again, you can look this up yourself at plasmascape.com, and that's today's cosmology segment. Next, getting back to some data about electrons, here's the one-year chart of the electron flux, the greater than 2 mega electron volt electron fluence. Here's the 3-day chart of that, and we're expecting it to remain cratered here throughout the coronal hole wind stream and then precipitously rise after that subsides. So here is the forecast model, and I would say this is going to be low again tomorrow and then probably pop up to these levels by Monday or somewhere around then. And I wouldn't be surprised to see us get into electron warning levels. Here's a diagram of the Van Allen belts. Feel free to pause the video. Here's a total electron content visualization. This is showing you the entire air column and the likely location of GPS errors. Now we see chaotic Van Allen belts at times of coronal hole wind streams. No surprise there to our regular viewers. Continuing on, here's another diagram of the atmosphere, and we're showing you this for the F over here. Are you F'd? Nope. But this layer is. It's the F ionosphere, located at about 300 kilometers of altitude. Here are the vibrational frequency visualizations of the ionosphere. And this data set is courtesy of Australian Government Bureau of Meteorology. And we're seeing pretty chaotic ionosphere activity here. Quite anomalous, actually. You're seeing large blobs of sudden charge up and charge down happening. So quite chaotic ionospheric behavior here. And this is not always accompanied by geomagnetic storms. In fact, it's usually not. And it's actually playing very slowly here. It looks like there may be some missing data as well. And that missing data could actually be caused by the geomagnetic storm. We don't always see anomalies in the ionosphere during geomagnetic storms, but today indeed we do. So let's just bring up the latest image here, as there's again missing data apparently on that. There's the most current image from 10:15 Universal Time, and it's looking normal there for the most part. We've got a very strong tropical cyclone here. I was clocking 100+ mile-per-hour winds earlier. Check it out. There's 118 mile-per-hour winds here off of the east coast of the Philippines. Let's zoom out to show you the rest of the surface winds of the eastern world. And there are the surface winds of the eastern world. Here are the jet streams. Very chaotic jet streams, all broken up and tripled up over places like the Middle East. And doubled up over the southern hemisphere as well. Here are the jets of the western world. Quite chaotic in both hemispheres as well. And here are the surface winds of the western world. Pretty strong winds continuing to persist in the North Atlantic, as well as off the coast of New England there. And also we've got these continuing low wind ridges here, these little troughs of very low wind speeds surrounded by areas of higher wind speeds, making for likely large pressure gradients in those areas. Speaking of pressure, here indeed is the pressure. And we're going to move this forward in the GFS forecast. This is the GFS forecast for pressure at 12 noon Eastern Daylight Time tomorrow. And if you're a new viewer, thanks for tuning in. If you're wondering where we're located right about here in Lehigh Valley, Pennsylvania. Shout out to SMASH staff. Next, a real-time lightning map. I like to use lightningmaps.org when I hear thunder. And we've got some lightning there just south of Texas. Fairly calm conditions as far as lightning. Here's a U.S. Doppler radar map. Quite a bit of rain across the southeastern portion of the U.S. and central portion of the U.S. Snow continues to fall in Colorado and Wyoming and Utah and New Mexico and Nevada, as well as northern New Hampshire and most of Maine, continuing to get snow here on April 17th. And if you didn't see our video from yesterday, check out our playlists again, youtube.com/smashamash/playlists. It was snowing in eastern Pennsylvania at 50 degrees on April 16th. Next, looking at the cloud layer, it's the NASA GOES shortwave radiation map. Here's a water vapor map. You can see this low pressure system continuing to rotate off the coast of Cape Cod. Again, there's water vapor, and there's the cloud layer. And once again, there's the Doppler. Thanks again to our patrons. Again, please consider becoming a patron at patreon.com if you'd like to see these videos continue to exist. And how about some current imagery in hydrogen alpha? 6,562.8 wavelengths. I mean, angstroms, rather. 6,562.8 angstroms. It looks like a cloudy day at Udaipur, India. And you can see some filament up here. Again, there is some possibility of sort of an Earth vicinity coronal mass ejection going on right now. And let's do bonus features. First, let's thank the Smash team. Hey, Smash team. Thanks for tuning in. Remember to press share. Tell your friends, foes, science noobs, and science pros about the channel. Here's a colorized magnetogram of sunspot 2816. And there's the intensity gram. You can see quite a lot of space between those umbrae. It is a beta class, and beta class sunspots are more likely to produce solar flares than alpha class sunspots are. Here's the most current image. And it stayed pretty steady while we did the show. Again, here's 193 angstroms, a full disk view. The coronal hole wind stream that's causing the geomagnetic storm conditions are from this coronal hole right down here, a south pole-oriented coronal hole, sending high-speed hydrogen nuclei primarily. About 90% of the material coming out of that are hydrogen nuclei, solar protons, whatever you'd like to call them, hydrogen atoms that really want an electron, ionized hydrogen. Here is the close-up of sunspot 2816 in 94 angstroms. You can see that solar flare toward the beginning of the video. I'll let it play through one more time. That little B-class flare happening there. And here's an extreme close-up of the magnetogram. Not a whole lot of changes or migrations going on with those magnetic fields. And last but not least, here's 335 angstroms. Thanks for tuning in, folks. Remember, stare at the sun. Use the proper instruments like our channel. And may that solar wind be at your back.